All right, so attack vectors for cross-site request forgery. Financial applications, huge. We find cross-site request forgery there a lot. Some of the really famous CSRF hacks over the past several years have been trading companies. Everybody uses the analogy of the trading company where, you know, Joey's logged into some trading site and I stay logged in because I'm a day trader, right? So I'm moving and shaking and doing things all the time. And then I happen to go visit a website that's got you know, an attack for this particular trading site. And then all of my funds get transferred, or it makes me invest in something that I'm not really interested in investing in. I have no control because the bad.com or evilsite.com is making those requests for me. Mashups like NetVibes, stuff like that, these are ripe for this type of thing. Ads. You know, I don't think it's any surprise to anybody in this room that a lot of the malware that we're dealing with botnets and stuff like that, you know, a lot of that's coming from these ad networks where you have rotating ads on the sites. And there's some crazy, and statistics are, you know, take them for what they're worth, but there was recently reported something like 60% of legitimate websites on the internet are serving malware to their users. Not necessarily from, you know, FishNetSecurity.com. For example, White Hat Security, actually, there was a cross-site scripting vulnerability that was found in White Hat Security's web application. It wasn't actually their site, it was one of the ads that was going through there that was actually vulnerable. So, you know, there's a lot of nasty stuff out there. iReports, blogs, forum, email, social networking, you know, pretty much you name it, routers, and in short, anything with a web interface that has been poorly designed or poorly coded, okay, is a potential attack vector. So what we're going to demonstrate today is an attack that was theorized in late 2007 by a couple of guys from Symantec called drive-by farming. And they basically just kind of, you know, postulated about the possibility of this attack. And then in early 2008, as you can see the post on the blog there is January 2nd, they actually saw this in the field, in the wild. So essentially what it is, at least the attack that we saw, which I'm going to recreate here today, in northern Mexico, 90% of the population uses the same Mexican national bank. They use the same Mexican national ISP, and that ISP gives them their broadband routers. So they're all using the same router, they're all banking at the same place, and they all use the same ISP. So what happened is there was a group of individuals that, you know, kind of put two and two together. They discovered some vulnerabilities in the broadband routers. And then what they did is drove around and reset all the users' DNS servers to DNS servers that they controlled. And then they put up a malicious version of the Mexican National Bank so that they could harvest credentials. They got usernames and passwords, and then they went and basically pilfered the bank accounts of those people. So we saw this in the wild. It was highly successful. And as far as I know, they have not been caught. They're probably hanging out in Antigua or something by now. All right, so we're going to get to the, so what I did is I went ahead and put some slides together because I wanted to be able to post this on the internet, and it didn't really make a lot of sense without having screenshots of the actual hack. So when I first did this, I didn't have these. So I'm just going to kind of run through these pretty quickly so that we can get to the demo. So this is the starting page. The default password, default admin password for this Netgear router is password. So the first idea that I thought was, hey, why don't I go change the password? So at the time, I obviously had changed my password and I couldn't remember what the default was. And I realized the first time I tried to pull off the attack that I had to have the actual password. So you have to have the old password in order to change it. Obviously, that's a non-issue with a lot of stupid users out there that don't bother to change their password, and we know that it is password, so technically we could probably still pull the attack off. But I thought, you know, let's do something different. That's how I ended up doing the drive-by farming. So admin password is how you get in. Some of the tools that you need for cross-site request forgery. So there's a couple of tools that you can use. Personally, I like Burp Suite Pro. I've been using it for a number of years. And I'm kind of old school, so I use an HTTP proxy. Using the HTTP proxy, you can look at the parameters or the elements of a request, and you're going to need to know this information in order to be able to rebuild the request on the fly and do what you want to do, right? So when I'm running this through an HTTP proxy, I intercept requests and responses so that I can look at what I'm sending and modify that potentially if I want to and send it off to the server. I can also look at how the server is responding to me. And you know, obviously I could modify that too if I chose to. So an important thing to note here is the referrer right here. So I talked to you guys a little bit about dynamic cross-site request forgery, slurping down the tokens, the anti-CSRF tokens, the authentication tokens, everything else that you need to be able to pull off an attack on a hardened application. Cross-domain referrer leakage is the primary way that we're able to sniff that stuff because typically it's embedded in the referrer. So that's another mitigating control that you can use when you're developing applications is make sure that you're not passing sensitive information like anti-CSRF tokens or authentication tokens in the referrer. So this is the tool that I like to use to examine the requests and responses and figure out how to build the proper request. There's another tool that you can use that is a plug-in for Firefox called Tampered Data. That's the one I have up here. A lot of guys actually use this now instead of an HTTP proxy, and you can see why. It's pathetically easy to see exactly what you need to do, right? And incidentally, these numbers that I have right here, so what I'm going to do, this thing, sorry, technical difficulties there. So this thing, by default, it actually has its own DNS server, so it's going to get DNS servers from the ISP, and then it's got its own internal DNS server as well. So it's currently, these values are zeros right now. So I'm going to change the configuration to the ubiquitous 41114222 DNS servers. Obviously, I don't control those servers, but for proof of concept purposes, it'll get the job done. So that's another tool that you need, and then obviously you don't need MonkeyFist to pull off CSRF exploitation, but it makes it a hell of a lot easier. So this is written in Python. It does run from the command line, and what you can see here, I've got the help up here, and then this is the output after successful exploitation. So you'll get to see this when we actually pull off the attack this afternoon. Is it'll just be blank, kind of like this right here. And then after we pull off the attack, then it'll have all the information in there that we used. The file on the right, that is the payloads file. It's an XML file, as you can see, and there's several different payloads that you can choose from. I'll show you that now. So here's the actual payload file. And I'm going to read this to you. I don't normally do this, but I'm going to read this to you. This is Nate's notes here. Remember, this has to be valid XML. You have to specify here, blah, blah, blah. Place the token, session ID, or other random data in the ID tags. Also, make sure you have a default payload specified. Otherwise, you may have some problems if you have a non-match condition. So essentially, there's several payloads you can choose from. I've removed the extraneous ones, and I just kept the one that I'm actually using for this particular attack. For this particular attack, we can handle anti-CSRF tokens if they're present. This is just a pathetically insecure CGI application, so it does not have anti-CSRF tokens. That's what the comment is here. Local host, I'm running MAMP on the Mac here, Mac, Apache, MySQL, etc. And that's going to actually simulate my the good.com or bad.com where you go and click on the link. So that's what the 888 is. And then also what I'm going to do here is you see where it says destination right here? So the cool thing is with MonkeyFist, we can actually pull off the attack and then we can redirect the user to a friendly page so they don't know what's going on.